Okay, time to do number 12. So it says bismuth 210 has a half-life of 5 days. And it gives us all of these questions. But before anything else, we have to figure out what the formula is for how much remains. And we can do that with our information that we have. So number 13. Number 13, 12, I can't count. Okay, so half-life 5.0 days. So there's a few things we can do here, or a few ways we can solve this. So one, we know that the half-life, this is a formula, is equal to the natural log 2 over k. What's k? Well, we also know that the amount remaining is an exponential function. So a of t is equal to a naught e to the minus kt. Minus because it's decaying. This gives us a chance to solve for k without being really, really sad. Because we know the half-life is 5 equals natural log 2 divided by k. Or in other words, k is equal to natural log 2 divided by 5. Okay, so this is our k. Now, we're good to solve the problems because we have k. And if you forget this formula, you can also find it using something similar that we're going to do in part A. So it's not strictly necessary you know that formula, it just makes things go quicker. So how long would it be for there to be 20% of mass remaining? So there's been a little bit of confusion about this in class, but 20% of mass remaining, what does that really mean? Means we have 0.2 A naught left, right? Take 20%, that's 0.2. So for example, 20% of 100 would be 20. In general, 0.20 A naught, but the 0 at the end of that doesn't do anything. So now we set this equal. We say 0.2 A naught equals A naught e to the minus kt. And from here we solve from t. So divide both sides by A naught, those cancel out. 0.2 equals e to the minus k, we also know, is natural log 2 divided by 5 times t. Now I'm going to take a natural log of both sides. Equals natural log of e means I'm just going to be left with the exponent. 2 over 5 times t, cross multiply and divide. I get t is equal to 5 natural log 0.2 divided by natural log of 2. And I can also throw on a minus sign. So now let's go ahead and plug that in. Minus 5 natural log of 0.2 divided by log 2 gives me roughly 11.61 days. Okay, so that's part A. B is actually really easy because we've done most of the work. A of t is A naught e to the minus, and then k was equal to minus natural log 2 over 5 t. And now it just tells me, well, it started with 1,000 milligrams, so we can plug that in for A naught. Okay. And that's our final answer. There. And here. And now C and D expect you to use what you had from D. So let's go ahead and do that. C and D make you want to use this one. So find the mass remaining after 10 days. All right, that just says plug in 10 is 1,000 e to the minus log 2 over 5 times 10. So let's plug that in. E to the minus log 2 divided by 5 times 10. And the answer is probably not syntax error. All right, so I get 250. And what would the unit be? Milligrams. And that's the answer to part C. And then part D flips the script a little bit. When is there 200 milligrams remaining? Or when is the mass 200 milligrams? So we go ahead and plug that in. 200 milligrams equals 1,000 e to the minus log 2 over 5 times not 10, but t. Now we solve for t. So 0.2 equals e to the minus log 2 over 5 times t. Natural log both sides again. Natural log 0.2 equals minus log natural 2 over 5 t. Hey look, this looks familiar. Why is that? Because this is actually the same problem as was A. So t is minus log 0.2 times 5 over log 2, which is, you can check this, log of 5 times 5 over log 2. And then you plug that into the calculator. And I looked like I plugged this number in already. Yep, 0.61. That makes sense because 200 milligrams is 20% of 1,000. So we actually could have been clever and noted that, but that's okay. Doesn't hurt to do it twice. Good practice. And that is number 12.